Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC, that is an equilateral triangle, and inside the big triangle ABC we have the green triangle, and also we know that AF equals to BF, and BD equals to 2 units, and the size of DC is 4 units, and actually the green triangle is a right triangle because angle FDE equals to 90 degrees. Angle FDE is a right angle, and we want to find out the area of this green triangle. Okay, first of all, in every equilateral triangle, all the angles equal to 60 degrees. All the angles are equal to each other, and all the angles in an equilateral triangle equals to 60 degrees. So angle ABC is also equals to 60 degrees, and also angle BCA equals to 60 degrees, and we also know that all the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. Okay, AB equals to BC equals to AC. Okay, but we know that BD equals to 2 units and DC equals to 4 units, and the size of BC, side BC of the equilateral triangle equals to BD plus DC. So when we know that BD equals to 2 units and DC equals to 4 units, so the size of BC is 2 plus 4, that is to say the size of BC is 6 units. So actually all the sides of the equilateral triangle ABC equals to 6 units. Okay, and we also know that AF equals to BF. So if we define AF as X, then BF that equals to AF will be also defined as X, and the size of AB is AF plus BF. Okay, AB equals to AF plus BF, and AF equals to X and BF also equals to X. So we can say that AB equals to X plus X, that is to say AB equals to 2X, but we know that AB also equals to 6 units. All the sides of this equilateral triangle ABC equals to 6 units, so AB also equals to 6 units. So from this equality we can say that 2x equals to 6 units. Okay, 2x equals to 6 units, and if we divide this equality by 2, we will get that x equals to 3 units. Okay, so x equals to 3 units. So BF that equals to x equals to 3 units, and also AF also equals to 3 units. So in the next step we will define FD as A, that is to say FD equals to A, and we will define side DE of the green triangle as B, that is to say DE equals to B, and then we will find the size of FD that equals to A by the law of cosines. What is the law of cosines? The law of cosines, actually the law of cosines is true for all the triangles. Okay, so the law of cosines states that in any triangle if we have triangle if this side of the right triangle is A, this side of the right triangle is B, and this side of the triangle is C, then we can say that C squared equals to A squared plus B squared minus 2 times AB, and if the angle between A and B is theta, it is minus 2AB cosinus theta. Okay, so this equality is true for any triangle, that C squared equals to A squared plus B squared minus 2 times A times B cosinus theta, when theta is the angle between side A and side B of the right triangle. Okay, again it is true for any triangle. Actually, we can implement the law of cosines in the small triangle BFD in order to find out the value of FD. According to the law of cosines, FD squared will be equal to BF squared plus BD squared minus 2 times BF times BD cosinus 60 degrees. Again, according to the law of cosines, in the small triangle BFD, FD square equals to BF square plus BD square minus 2 times BF times BD cosinus 60 degrees. Again, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, and FD is defined as A, so FD square is A square equals to BF square. BF is equals to 3 units, so BF square is 3 square. 3 square is 9 plus BD square. BD equals to 2 units, so BD square is 2 square, and 2 square is 4, minus 2 times BF is 3 units, times BD is 2 units, times cosinus 60 degrees. Cosinus 60 degrees equals to 1 over 2. So, in total we got that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. Here we have 2 in the numerator and we have 2 in the denominator, so we can cancel 2, and what is left is that A square equals to 9 plus 4 is 13, and 3 times 2 is 6. So in total we have A square equals to 13 minus 6. Okay, 13 minus 6 is 7, so we got that A square equals to 7, and if we take a root out of this equality, we will get that A equals to the root of 7 units. Okay, so we found out the value of A. A equals to the root of 7 units. Okay, in the next step we will define angle BFD as theta. This angle will be equal to theta, and we will define angle BDF as alpha. Then we will define angle EDC as gamma, and we will define angle DEC as beta. And we will find out the value of sinus theta according to the law of sines. what is the law of sines? The law of sines. The law of sines states that in any triangle, it is true for any triangle, we have the following relationship between the sides of a triangle to its angles. If we have a triangle if this side of the triangle of the red triangle is A, this side of the red triangle is B, and this side is C, and if this angle of the red triangle is alpha, if this angle of the red triangle is beta, and if this angle of the red triangle is gamma, then the following relationship exists between the sides of the triangle to the angles of the red triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. It is true for any triangle. Okay? A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? Again, we can implement the law of sines in the small triangle BFD in order to find the value of sinus theta. Actually, according to the law of sines in triangle BFD, a small triangle BFD, FD over sinus 60 degrees equals to BD over sinus theta. Again, in the small triangle BFD, according to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Okay? FD over sinus 60 degrees equals to BD over sinus theta. Okay? But what is the value of FD? We have already found out that the value of FD that equals to A equals to the root of 7 units and sinus 60 degrees equals to the root of 3 over 2. BD equals to 2 units, and sinus theta is sinus theta. So we got that root 7 over root 3 over 2 equals to 2 over sinus theta. Here we can move 2 to the numerator of this expression, and root 3 we can move it in the, we can move 2 to the numerator of this expression, and we can move root 3 to the denominator of this expression, and we will get that 2 times root 7 equals to 2 times root 7 over root 3 equals to 2 over sinus theta. Okay, 2 times root 7 over root 3 equals to 2 over sinus theta. We have 2 in the numerator of this side of the equation, and we have 2 in the numerator on the other side of the equation, so we can cancel 2. And what left after we cancel 2? 1 over root 3 equals to 1 over sinus theta. Okay, we got that 1 over root 3 of course we have here also root 7. It is root 7 over root 3. Root 7 over root 3 equals to 1 over sinus theta. Okay, so we can multiply this equality by sinus theta. After we multiplied this equality by sinus theta, we got that root 7 over root 3 equals to times sinus theta equals to 1. Okay, now again we will multiply this equality by root 3. We will get that root 7 times sinus theta equals to the root of 3 we multiply this equality by root 3, and we got that root 7 times sinus theta equals to root 3. We will divide this equality by root 7, and we will get the value of sinus theta. We will get that sinus theta equals to the root of 3 over root 7. So we got the value of sinus theta. Sinus theta equals to the root of 3 over root 7. In the next step, we'll find out the value of cosinus theta, and by we will present a trigonometric identity and from the trigonometric identity we will get the value of cosinus theta. The trigonometric identity is sinus theta squared plus cosinus theta squared equals to 1. Okay, we have this trigonometric identity, sinus theta squared plus cosinus theta squared equals to 1. Now we will subtract from this trigonometric identity sinus theta squared, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, after we subtracted sinus theta squared from this trigonometric identity, we got that cosinus theta squared equals to 1 minus sinus theta squared. In the next step, we will take a root out of this equality, and we will get that the value of cosinus theta is the root of 1 minus sinus theta squared. Okay, the value of cosinus theta equals to the root of 1 minus sinus theta squared. But we know that the value of sinus theta is root 3 over root 7. The value of sinus theta is root 3 over root 7. Okay, the value of sinus theta is root 3 over root 7. If the value of sinus theta is root 3 over root 7, then the value of sinus theta squared will be 3 over 7. Okay? The value of sinus theta squared will be equal to 3 over 7. Okay? The value of sinus theta squared equals to 3 over 7. So we can substitute sinus theta squared from this equality by 3 over 7, because sinus theta squared equals to 3 over 7. So we will get that cosinus theta equals to the root of 1 minus 3 over 7. Okay, we substitute sinus theta squared by 3 over 7, and we got that cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7. So I write it down. Cosinus theta equals okay, 1 minus 3 over 7 equals to 4 over 7, and the root of 4 is 2, so I write it down. So we got that cosinus theta equals to 2 over root of 7. Okay, cosinus theta equals to 2 over root 7. And we have already found out that sinus theta equals to the root of 3 over root 7. Sinus theta equals to the root of 3 over root 7. Okay, so we found out the value of cosinus theta and the value of sinus theta. Okay, so in the next step we will create 4 equations. The first equation that we will create states that the sum of the angles in any triangle, and especially in triangle BFD, equals to 180 degrees. Okay, so in triangle BFD, the sum of the angles equals to 180 degrees. Okay, triangle BFD, the sum of its angles equals to 180 degrees. That will be our first equation. So what is the sum of the angles in triangle BFD? It is actually 60 degrees plus alpha plus theta, and it equals to 180 degrees. Okay, so equation number 1 states that the sum of the angles in triangle BFD equals to 180 degrees. Our second equation will be in triangle DC, the sum of its angles equals to 180 degrees. What is the sum of the angles in triangle DC? It is 60 degrees plus gamma plus beta, and we know that the sum of the angles in any triangle, and especially in triangle DC, equals to 180 degrees. Okay, so that will be our second equation. Again, our second equation states that the sum of the angles in any triangle, and especially in triangle DC, equals to 180 degrees. In the next step, we will add equation number 1 to equation number 2, and the addition of equation number 1 to equation number 2 will be equation number 3. Okay, so equation number 3 will be the addition of equation number 1 to equation number 2. So 60 degrees plus 60 degrees equals to 180 degrees, 120 degrees, again 60 degrees plus 60 degrees equals to 120 degrees. And here we add all the angles here, we have 4 angles and we add them together. So it will be alpha plus theta plus gamma plus beta and we added equation number 1 to equation number 2, and the other side of the equation we'll have 180 degrees plus 180 degrees equals to 360 degrees. So we created equation number 3, that is the addition of equation number 1 to equation number 2. 180 degrees plus alpha plus theta plus gamma plus beta equals to 360 degrees. Okay, now we can subtract from equation number 3 180 degrees. Okay, and we will get that alpha plus theta plus gamma plus beta plus gamma plus beta equals 360 degrees minus 120 degrees equals to 240 degrees. Okay, so after we subtracted 180 degrees from equation number 3, we got that alpha plus theta plus gamma plus beta equals to 240 degrees. Okay, in the next step we will create equation number 4 that states that the sum of the angles in the upper side of any straight line or line segments equals to 180 degrees. So if we look at the straight line BC at point D, the sum of the angles in the upper side of the straight line BC equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, alpha plus 90 degrees plus gamma equals to 180 degrees. It is also true to say that the sum of the angles in the lower side of line segment BC equals to 180 degrees, because this angle is 180 degrees. Okay, so the sum of the angles around the point is 360 degrees. Okay, so, and the sum of the angles in the upper side of the straight line is 380 degrees, and also the sum of the angles in the lower side of a straight line equals to 180 degrees. So we got equation number 4 that states that the sum of the angles in the upper side of line segment BC equals to 180 degrees at point D. So alpha plus 90 degrees plus gamma equals to 180 degrees. We will subtract 90 degrees from equation number 4. We will get that alpha plus gamma equals to 90 degrees. Okay? So after we subtracted 90 degrees from equation number 4, we got that alpha plus gamma equals to 90 degrees. We have alpha plus gamma also in equation number 3. In equation number 3 we have here alpha plus gamma. Okay, so we can substitute alpha plus gamma in equation number 3 by 90 degrees because alpha plus gamma equals to 90 degrees. Okay, so we will substitute alpha plus gamma in equation number 3 by 90 degrees. Okay, we'll get that 90 degrees plus theta plus beta equals to 150 degrees. Okay, we substituted alpha plus beta in equation number 3 by 90 degrees because we subtracted alpha plus gamma in equation number 3 by 90 degrees because of the fact that alpha plus gamma equals to 90 degrees. So we substituted alpha plus gamma from equation number 3 by 90 degrees because alpha plus gamma equals to 90 degrees, and we got that 90 degrees plus theta plus beta equals to 150 degrees. In the next step, we will substitute 90 degrees from equation number 3, and we will get that theta plus beta I made a mistake here. Actually, after we substituted alpha plus gamma by 90 degrees in equation number 4, we have alpha plus gamma. We wrote here 90 degrees instead of alpha plus gamma plus theta plus beta, all equals to 240 degrees. Okay, it equals to 240 degrees, and here we'll substitute 90 degrees from equation number 3, and we will get that theta plus beta equals to 150 degrees. Okay, so we got that theta plus beta equals to 150 degrees. In the next step, we'll substitute theta from equation number 3, and we will get that beta equals to 150 degrees minus theta. Okay, we got that beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay, so sinus beta equals to sinus 150 degrees minus theta. Okay, very simple. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. What is the value of sinus 150 degrees minus theta? Actually, in order to find out what is the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta is sinus alpha cosinus beta minus minus sinus beta cosinus alpha. Okay, so we have the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. We will use this identity in order to find out the value of sinus 150 degrees minus theta when alpha will be equal to 150 degrees and beta equals to theta. Okay, and we'll find out that sinus of 150 degrees minus theta equals to sinus 150 degrees times sinus theta minus sinus theta Okay, we found out the value of sinus 150 degrees minus theta according to the trigonometric identity of sinus alpha minus beta, and the value of sinus alpha minus sinus alpha 150 degrees minus theta is sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. So, what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2. We have already found out the value of cosinus theta. The value of cosinus theta is 2 over root 7 minus sinus theta, and we know that the value of sinus theta is root 3 over root 7, and the value of 100 of cosinus 150 degrees is minus root 3 over 2. So in total we got that 1 over 2 times 2 over sinus beta minus root 3 over 7 times minus root 3 over 2 all equals to sinus 150 degrees minus theta. But we have 2 in the numerator of this expression and 2 in the denominator, so we can cancel 2, and minus times minus is plus, and root 3 times root 3 is 3. So this is the value of sinus 150 degrees minus theta, but sinus 150 degrees minus theta equals to sinus beta. So we actually calculating the value of sinus beta. It equals to 1 over root 7 minus one over root 7 3 over 2. So we got the value of sinus beta. Sinus beta equals to 1 over root 7 minus 1 over root 7 times 3 over 2. Here we can take 1 over root 7, we can take out 1 over root 7 as a common factor of this expression. Okay, and we will get that sinus beta so we got that the value of sinus beta equals to 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is 2.5 or 5 over 2. So I write it down. The value of sinus beta equals to 1 over root 7 times 5 over 2. Okay, so the value of sinus beta equals to 5 over root 7 times 2. Okay, after we found the value of sinus beta, we can implement the law of sines in order to find out the value of dE, that is B. Okay, actually after we will find out the value of B, we will know the area of the green triangle, because the area of the green triangle is the base of the triangle that is B times the height of the triangle that is A over 2. Okay, so the only missing variable that we have to find out in order to get the area of the green triangle is B, and we will find the value of B by implementing the law of sines in triangle DC. Okay, so in triangle DEC, the small triangle DEC, this triangle, we will implement the law of sines in order to get the value of B. So in triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Okay, DE over sinus 60 degrees equals to DC over sinus beta. Okay, again, in triangle, the small triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. What is the value of DC? DC equals to 4 units. And we have already found out the value of sinus beta. The value of sinus beta is 5 over 2 times root 7. All equals to DE. DE equals to B over sinus 60 degrees. What is the value of sinus 60 degrees? Is actually root 3 over 2. Okay, so we got that 4 over 5 over 2 times root 7 equals to B over root 3 over 2. So here we can do the simple arithmetic by moving 2 times root 7 to the numerator and by moving 5 to the denominator, and then here we will move 2 to the numerator and root 3 to the denominator, and we will get that four times 2 times root 7 over 5 equals to 2 times B over root 3. Okay, after we did the simple arithmetic, we got this expression. Here we have 2 in the numerator on this side of the equation, we have 2 in the numerator of the other side of the equation, so we can cancel 2. What left after we cancel 2 is actually 4 times root 7 over 5 equals to B over root 3. Okay, that is what left after we cancel 2 in this equality. Here we will multiply this equality by root 3 in order to get the value of B. Okay, So we found the value of B. The value of B equals to 4 times root 7 times root 3 over 5. Okay? Again, the area of any triangle equals to the base of the triangle times the height to the base over 2. And the area of triangle, the green triangle FDE, will be equal to the base of the triangle times the height to the base over 2. The base of the triangle is B, the height of the triangle is A. The height is A because A creates 90 degrees with the base. For that reason, the height is A, because A creates 90 degrees with the base B. So it is B times A over 2 square units. Okay? So that is the formula for the area of the green triangle FDE, A times B over 2. We have already found out the value of A. The value of A is root 7. And the value of B is root 7 times root 3 times 4 over 5, and all divided by 2. Okay, so the area of triangle FDE equals to this expression. Here 4 over 2 is 2. So I write it down again. So the area 4 over 2 is 2, and root 7 times root 7 is 7. So I write it down. So we got that the area of the green triangle FDE equals to 2 times 7 times root 3 over 5. 2 times 7 is 14, so I write it down. So the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Okay, so the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. So the area of the green triangle FDE equals to 4.85 square units. Again, the area of the green triangle FDE, this green triangle, equals to 4.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle FDE, and the data that we have in the question is that we have an equilateral triangle ABC. ABC is an equilateral triangle. So in any equilateral triangle, all the angles are equal to 60 degrees. So this angle is 60 degrees, this angle is 60 degrees, and this angle is also equals to 60 degrees. And all the sides in any equilateral triangle are equal to each other. So AB equals to BC equals to AC. And we also know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units. So we actually can get the size of the side of the triangle ABC, because we know that BD equals to 2 units and DC equals to 4 units, and BC equals to BD plus DC. So actually BC equals to 2 units to 4 plus 4 units. So BC equals to 6 units, so AB also equals to 6 units, and AC equals to 6 units. Okay, and we defined AF as X. So if AF is X and AF equals to BF, then BF also will be defined as X. And we have already know that AB equals to 6 units. So we can say that AF plus BF equals to AB. And AF equals to X. And BF also equals to X. So AF plus BF equals to 2X. So actually we can say that 2X equals to AB, that equals to 6 units. Or 2X equals to 6 units. And we can divide this equality by 2, and we will get that X equals to 3 units. X, that is BF, equals to 3 units, and X is also AF, so AF also equals to 3 units. In the next step, we defined FD as A and DE as B, and we found out the value of FD, that is A, by implementing the law of cosines in the small triangle FBD, this small triangle FBD. According to the law of cosines, in any triangle, the following relationship exists between the sides of any triangle. C square equals to A square plus B square minus 2 times A times B times cosinus the angle between A and B minus cosinus theta. So C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so we can implement the law of cosines in triangle, the small triangle BFD. According to the law of cosines, FD square will be equal to BF square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay? According to the law of cosines, in triangle FBD, FD square equals to BF square plus DB square minus 2 times BF times BD times cosinus 60 degrees. Okay, and we actually have all the values of all the variables here, and the only missing variable is FD, so we put the data inside this equality and we got that the value of A is root 7 units. Okay, A, FD is equals to A equals to root of 7 units, and it is actually also one side of the green triangle. So what is left is to find the other side B of the green triangle, and because of the fact that the green triangle is a right triangle, the area of the green triangle will be B times A over 2, because this angle is 90 degrees, so B is the base, the height is A because it creates 90 degrees with the base, so B times A over 2 will be the area of the green triangle. Okay, so in the next step we defined angle BFD as theta, angle BDF as alpha, angle CDE as gamma, and angle DEC as beta. And then we implemented the law of sines in triangle BFD. What is the law of sines? The law of sines applies for any triangle. In any triangle, the following relationship exists between the sides of the triangle to its angles. In any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. It is true for any triangle. So we can implement the law of sines in triangle BFD, the small triangle BFD. According to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. And in this way we actually will get the value of sinus theta, because sinus theta is the only missing variable. According to the law of sines in small triangle FBD, FD over sinus 60 degrees equals to BD over sinus theta. And we know that FD equals to the root of 7, BD equals to 2 units, and 60 degrees is root 3 over 2, so the only missing variable is sinus theta. So we solved this simple equation and we got, and to the value of sinus theta, we found out that the value of sinus theta equals to the root of 3 over root 7. And in the next step, we found out the value of cosinus theta by the first trigonometric identity. The first trigonometric identity states that sinus theta squared plus cosinus theta squared equals to 1. Okay, we subtracted sinus theta squared from this first trigonometric identity, and we got that cosinus theta squared equals to 1 minus sinus theta squared. We took a root out of this equality and we got that cosinus theta equals to the root of 1 minus sinus theta squared. But we have already found out that the value of sinus theta is root 3 over root 7. Okay, so we can substitute sinus. So if sinus theta equals to the root of 3 over root 7, then sinus theta squared will be equal to 3 over 7. So we can substitute sinus theta squared by 3 over 7, because 3 over 7 equals to sinus theta squared. Okay, so I substituted sinus theta squared in this equality by 3 over 7, and we got that cosinus theta equals to the root of 1 over 3 over 7. 1 over 3 over 7 is 4 over 7, and the root of 4 is 2, so we got that the value of cosinus theta equals to 2 over 7. And we have already found out that the value of sinus theta equals to the root of 3 over root 7. Okay, in the next step, we created 4 equations. Equation number 1 states that the sum of the angles in any triangle, and especially in triangle BFD, this triangle, equals to 180 degrees. Okay, our first equation states that the sum of the angles in triangle BFD equals to 180 degrees. And then we created our second equation that states that the sum of the angles in this triangle DEC equals to 180 degrees. This is actually our second equation. And we created the third equation by adding equation number 1 to equation number 2. So equation number 3 is the addition of equation number 1 to equation number 2. Okay? So that is our third equation, and we created our fourth equation that states that the sum of the angles in the upper side of any straight line or line segments equals to 180 degrees. The sum of the angles in the upper side of the straight line BC at a certain point, at certain D, at the point D, equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, the sum of the angles in the upper side of any line segment or straight line equals to 180 degrees. Alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, this is our fourth equation. For the fourth equation, we got that alpha plus gamma equals to 90 degrees. Then we substituted alpha plus gamma in the third equation by 90 degrees. And we got to the equality that states that beta equals to 150 degrees minus theta. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. And we calculated the value of sinus 150 degrees minus theta by the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so I found out that the value of sinus 150 degrees minus theta, that is actually also the value of sinus beta, equals to 5 over root 7 times 2. Okay, the value of sinus beta equals to 5 over root 7 times 2. Okay, so after we found out the value of sinus beta, then we implemented the law of sines in triangle DEC. In this triangle, we can say that DC over sinus beta equals to DE over sinus 60 degrees. Again, DC over sinus beta equals to DE over sinus 60 degrees. And DE equals to B. DC equals to 4 units, and we have already found out the value of sinus beta. So the only missing variable that we have here is B. So after the calculation of this equality, we get that the value of B is actually 4 times, value of B is 4 times root 7 times root 3 over 5 units. Okay, so we actually know already the value of A, we know the value of b, so the area of the green triangle will be a times b over 2. Okay, the area of the green triangle is the base of the triangle, that is b, times the height of the base, that is a, over 2. The area of the green triangle FDE equals to a times b over 2. And we have the value of a is root 7, the value of b is this expression. So we put the data inside this equation, and we found out that the area of the green triangle equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Again, the area of the green triangle equals to 4.85 square units. Okay, thank you very much.